we have this test. Question number 1, whatever the question is. And you have some answers, A, B, and C. Question number 2, A, B, and C, the answers. Question number 3, A, B, and C. Question number 4, A, B, and C. I'll do 5 questions on this quiz. Now you have 5 answers. Now X is the number of correct answers on this test. Number of correct answers. So I'm going to make what we call probability distribution table. If X represents the number of correct answers, could you have a 0 on this test? Could you get a 0 on it? Is it possible? Yes. So it is possible to get a 0 on this test. 0 correct answers. So these are your possible outcome. Is it possible to get only 1 correct answer? Yes. 2 correct answers? Yes. 3 correct answers? Yes. 4 correct answers? Yes. And 5 correct answers? Yes. These are all your possible outcomes. If I find the probability of each one of these and add them, you will find that the sum here, if I find the answer to each one of these and add them, you will find that the sum here when you add them is actually 1. That's one of the conditions for a probability distribution table to be correct. That if you take all the probabilities and you add them, if you sum them all, the answer is always a 1. If you take the answer to this, plus this, plus this, plus this, plus this, plus this, add them, you should have a 1. And the other one, the probability of any one of these cases, if any one of them, it's always between 0 and 1. The probability of any of these cases has to be between 0 and 1. Here's the question. What is the probability at least 1 correct answer? At least 1. What does that mean if you saw that?
1
or more. That means I got to find this answer. I got to find this answer. I got to find this one. I got to find that. And I got to find this and add them. Every one of them. Well, how many values do you got to find? 1, 2, 3, 4, 5. Let me show you how it's not really fun finding all these answers. Let me just do it for one case. 1 correct answer. How do you get 1 correct answer? Well, 1 correct answer, it could happen if question 1 is correct, number 2 is wrong, number 3 is wrong, number 4 is wrong, and number 5 is wrong. That's one way of doing it. 1 correct, I'm talking about this case. 1 correct answer also, it could happen if the first one is wrong, correct, wrong, wrong, and wrong. Bless you. It could happen this way. It could happen also this way. Or it could happen this way. There's 5 different ways you can have 1 correct answer. That means I got to find the probability of this, add to it the probability of this, add to it the probability of this, add to it this one, add to it that one. And add them, and that's the answer for this case only. For 1. Then I got to repeat the process for 2, for 3, for 4, and for 5.
Sounds like a lot of work.
It is. Now let's see what the answer to this one, getting the first question right. Assuming every question has only 1 correct answer, so to get the correct answer for question 1 is 1 out of 3 choices. So for the correct answer is 1 out of 3. for the wrong answer on question number 2 will be what? 2 out of 3. The next question, 2 out of 3, 2 out of 3, and 2 out of 3. That would be 2 times 2 is 4, times 2 is 8, times 2, that's 16 over. 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243, I think. But that's for this case. And it's going to be the same thing for this, the same thing for this, the same thing for this, the same thing for that one. So it's going to be 5 times 16 over 243. It's 5 cases, all going to be identical. So the answer to this is 80 over 243. I won't do the rest of them, but just give you an idea. To get 2 correct answers, look at how many choices you have. Could be this way. Could be that one. Could be this one. Could be this one. That's 2 correct answers. Could be this one. Could be this one. Could be this one. Could be this one. That's how you get 2 correct answers. How many choices? Let's look at them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the probability of one case and multiply it by 10. For one case, this will be what? To be correct is 1 out of 3. To be correct, 1 out of 3. To be wrong is 2 out of 3. 2 out of 3, and 2 out of 3. It's 8 out of 2 for one case. One case is going to be 8 over 243. But I got 10 cases here. That'll be 80 over 243. Now I got to figure out 3 correct answers, 4 correct answers, 5 correct answers. Or I can be smart. At least one. It says, wait a minute, since the number is going to be 1, why not find this number? Find what that number is and take 1 minus that number. So that's the rule I'm going to use. The probability of at least 1. I want to show you the struggle if you decide to do it the long way. That will be the struggle. So from now on, when you see the probability of at least 1, I'm going to use 1 minus the probability of none. That's the rule I'm going to use. It's called the complement. Now, to get no correct answer, it's really straightforward. It's one case. How? If you have this test and you want to get no correct answers, that means what? You get the first question wrong, the second one wrong, the third one wrong, the fourth one wrong, the fifth one wrong. There is no other way. That's it. That's the only way. To get this one wrong, that's what? 2 out of 3, 2 out of 3, 2 out of 3, 2 out of 3, and 2 out of 3. Is that 32 over 243? So that would be 1 minus 32 over 243. What's your chance of getting at least 1 correct answer on this quiz? 243 minus 32. What's that? 211 is it? Over 243. A lot quicker and easier. I don't have to find the answer to each one and add them. It's the same thing. I'll find the answer to 0 and 1 minus that number. It's called the complement. Where we use another example. DVDs, CDs. When you buy a computer, they send you a CD with it, or you buy TurboTax, do your taxes. Well, the company Intuit that makes TurboTax might say, you know what? Our CDs have a defect rate equals 0.5%. Very small. That means the probability of one CD being defective is 0.005. That means the probability of CD is not defective, which means what? It's good, is what? What's the chance that CD is good? Yep, 1 minus 0.005, which is 0.995. You have a 99.5% chance that the CD you got from us is a good CD. Now Costco gets a box of CDs from TurboTax. Here's the box is labeled. It says TurboTax on it. And it says 50 CDs on it. 50 of them. And the question, what is the probability of at least one CD is defective? One defective CD. When you take a box of 50, what's the chance of one of them is being defective? Again, the outcome of this table, if you try to make a table, get 50 CDs, X is the number of defect. You could have 0 defect, could be 1 CD, could be 2, all the way to how many? All 50 of them. If you got, somehow you get a box when the machine started acting funny, it is possible to have all 50 CDs are defective. The chance of that happening is almost 1 in gazillion, very small. But it is possible. I'm saying, what is the chance at least one defective CD? That means it could be one or more. Do I really want to find the answer to each one of these and add them? Hell no. I know the sum is going to be 1 at the end. So I'm going to use that equation 1 minus the probability of none. What's the chance none of the CDs are defective? Well, none of them are defective. That means what? The first CD was good. The second CD was good. The third one is good all the way to what? The 50th one is good. This is 0 defect or none. Well, for the first one to be good, what's the chance that one CD is good, or that each CD is good? 0.995. What's the chance the second one's good? 0.995. What's the chance the third one's good? 0.995. 0.995. So the answer of at least one going to be 1 minus the answer to this. Well, what's the answer to that? 0.995 to what power? 50. One minus 0.994. Oh, gotta turn it on. 1 minus 0.995 to the power of 50. 0.222. So there's a 22% chance, or 22.2% chance, that at least one CD will be defective. Again, without having to find the answer to each one of these. Let me also talk about conditional probability. Now remember, the probability of A and B, we said if the events are dependent, it's the probability of A times the probability of B given A. Now take that equation and solve it for the probability of B given A. So if you take this equation, solve it, you end up with this one. The probability of B given A, knowing A already happened, is the probability of A and B divided by the probability of A. That's what conditional probability is. We know this condition that A already happened. So what's the chance B will be selected knowing A already happened? Okay, an example for that. Let's take a blood test. You know I test my blood every week. So let's do it. Sometimes the machine actually gives you a false reading. So this is positive drug test. And my test nothing to do with drug, by the way. And this column is negative drug test. Sometimes the machine gives you false reading. Let's test it on the people we know they use drug. Subject or subjects uses, we know they use drugs. We ask them, you guys use drugs? Yes, I do. They're not shy about it. And we test them. That's 44. The result came out, yes, confirm. That's actually what we call true positive. We know they're drug user and the test came out positive. And for some reason, 6 of them who used drug, the test came out negative. That's called false negative. The test is wrong here. It came out negative, and it really shouldn't be. It should be positive. Now, the next group we're going to test it on, subjects, does not, or subject, I guess, do not, I don't know. These people do not use drugs. We know they don't use them. And the test confirm that, 90 of them. Saying, oh, actually, this didn't confirm them. This one says, you tested positive, knowing these people don't use any drugs. That's a false positive. It came out positive, but we know it's wrong. This one came out negative, we know it's wrong, that's why it's false. False negative, this is false positive test result. Now 860 people do not use drugs, and the test says, yep, you're right, you don't use them. That's true negative. Now, given these samples, here's the question. What is the probability if we select a person, the subject uses drug, given subject tests positive? What is the probability of that? If I try to use this equation here, it says, well, it's going to equal to the probability the person actually uses drugs. I'm tired of writing the word subject. Uses drugs and test positive over the probability of the A is the second one, the subject actually tests positive. By the way, if we add these numbers, which I forgot to add them, I can add them right now. I should have added them. 40 and 90, which is what? Positive test drug. That's 134. Negative is what?